These are the example items from our Algebraic Reasoning Fall 2018 ACP. This is the first ACP ever in our district for this subject, and these are the only sample problems we have, which are 15 of them. And so by these 15 items, we're supposed to get an idea of the rigor and kind of the scope of what's going to be on that test here in a few weeks. So what I'm going to do is go over all these 15 problems consecutively and then see what you get out. My suggestion is to go ahead, if you come upon this video, try to work out a problem first. Then after having worked out the problem, play it, see if you got it right. Problem 1, a tree's age is estimated by measuring its circumference and comparing it to data from identical species in the same environment. Data set for southern region hickory tree is shown, and here you have a table. And the way these tables are set up, this would be like, this top row would be like an input coordinate, like an X coordinate, and the bottom row would be like a Y coordinate. And so that's a kind of a sideways table. You'll see that sometimes. The circumference C after A years is modeled by the function C equals M times A. That says MXA. Well, I'd rather you write it as MA, where M is the growth rate of the circumference per year based on the data table. What is the value of M to the nearest hundredth? So basically what you're looking at here is a slope, a change in Y over change in X. And you can do this in a number of ways. One thing you can do is you can just take 2 points together like this. Like it would be like 2.98, and then you have the next point, and here is 3 years. You have 4.47, and so you can subtract. On the left side, 3 minus 2 is 1. On the right side, you have 4.47 minus 2.98, which is 1.49. So that would give you an M of 1.49. But even better would be to go down to this eighth. At 8 years, you have 11.92. And here on the left side, you have a span of 6 years. On the right side, you have 11.92 minus 2.98. So you get an average that way. So I'm going to go to the calculator to show you what that is. We add a calculator. Computer's a little slow. Okay. So let me get the right calculator page. I just want to get the side screen. There it is. Okay. Keypad plus side screen. There we go. Let's try. Yeah, this will work. So now we're going to take the numerator here, 11.92 minus 2.98, and we divide that by, in our denominator, 8 minus 2. Press enter, we get 1.49. So just like we got earlier, so M equals 1.49. And so that's going to be our answer. And then to enter this here in the grid, sure use the correct place value, you can put 1.49. And you just have to make sure you're consecutive. You could put 1.49 over here to the far right. And the grid assumes plus if you put nothing in there, but I just marked in plus anyway. So you have 1 point, that's where the decimal point goes right here. And then you have 49. Okay, next problem 2. The key attributes of the function fx are shown. Which key attribute? And so you have a domain, a range, a x-intercept, a y-intercept. Which key attribute is true for the inverse of fx? Well, one thing in the studying of inverses we did, in inverses, x's becomes y, and then also y becomes x. So it's like x's and y's will switch places, and we're going to see this. And so the domain in our original function, if we have a domain of x between 1 and infinity, our range is going to be the same as this. But is our range the same as this? As that domain in the original? No, it's not. Next, the range of y is greater than negative infinity but less than infinity should be the domain in the, okay, is that the domain here? That looks like A could be right, because that's the opposite of the, it's the same thing as the range. X-intercept would translate to a y-intercept of 2, x-intercept 0 of 2, 0 would translate to a y-intercept of 0, 2. Do we see a y-intercept of 0, 2 here? No, we don't. This y-intercept would switch to, of 0, negative 1, would switch to an x-intercept of negative 1, 0. Do we see that here? No, we don't. So A is definitely our correct answer. So x becomes y, y becomes x. Domain of one function is the range of the inverse, and so forth. Next, 2. What is the range for this function? So in my class, what I've been showing is a little diagram that sort of shows graphically the relationship to domain and range. And so I write out just like a crossword puzzle. So you write domain horizontally and then range in crossword puzzle fashion vertically. And so the y is the range. So the range would be the y values. And we should be able to see that we start here at y equals negative 6. So that would leave off answer choices A and B. And now we're choosing between C and D. What you have is you have a, and you might be able to see it, you have a closed circle here, which is going to be analogous to a bracket. Up here you have an open circle at 8, which is analogous to a parentheses. Okay, so you should see you have different. You're going to have different in any case. And so your correct answer is going to be C. So that's problem 3. 4. Students' physics class build a rocket in a 4-foot launching pad at the time of launch. Students closely monitor the rocket's height for the first 8 seconds of flight as shown in the table. Which interval correctly describes the domain? Okay, again, domain would be x. So this would be analogous to x. Range would be y. The height will be the y. The time will be like the x. And so your domain is going to be related to these values here in the upper row, input values. So definitely you start at 0. You're not going to get any number near 200, 300. C and D are out. Okay. Now you're between A and B, and just based on what you see in the table, you have to consider what you have physically. Okay? You have a rocket that's launched from 4 feet here, and it goes up, and we can sort of look at the height here. We'll say 100 feet, 200, 300, and then the time, we have 1, 2, 3, 5, 6, 7, 8 seconds. We can sort of chart where it goes. At time equals 0, we have 4 feet of height, so it'd be about right here, just barely off the ground. At 1 second, we have 144 feet, so at 1 second, we're going way up here. At 2 seconds, we have 252, so we're still going quite high. At 3 seconds, we have 328, so 328 would be about right here. At 4 seconds, we have 372, so it'll be right up here. At 5 seconds, we have 384, so we're still going higher. At 6 seconds, we have 364, so we're coming down a little bit here. And at 7 seconds, we have 312 feet. And at 8 seconds, we have 228 feet, something like this. So the rocket is going like this, okay? And this is where it stops at 8 seconds, according to the data in the table. But we know this rocket is going to keep on going toward the ground. And so the answer that makes the best sense, that's going to be answer choice B. So that's not the easiest problem in the world, but you can also go to list and spreadsheets, data and statistics to plot these points and see what happens there. Next, 5. The table values for a function is shown. What is the finite difference in linear function? And one thing we call finite difference, we would call that in our class, as you might recall, common difference. And then common difference, and in function language, that's going to be called the slope. So we're say that you're told this is a linear function, so you're only going to need 2 points. So you can take any 2 points and subtract. So we took 12 minus 18, we get negative 6. And then left side we have 5 minus 3, which is 2. So our m is going to be equal to negative 6 over 2, which equals negative 3. So that should be quite an easy problem. One thing you should notice is that x values are increasing while the y values are decreasing, and so we're going opposite directions. So you could eliminate immediately your positive answers, then you'd be between choices A and B. Next. 6. Many lizards are known to grow over their entire lifespan. The growth of a particular lizard is shown in the table. Which type of function models the lizard's growth with respect to time? So I don't think it's exponential, but let's go do an analysis. If you don't know what it is, my idea is just try to work on try to look at first differences. You know on the left side that you're going up by +1 every time. Okay, we see that, +1, so on. On the right side, if we subtract, let's see, 4.8 minus 1, that's going to be 3.8. And the next one we have is 8.1 minus 4.8. Let's see, that's going to be 3.3. Is that right? I hope that's right. Isn't that right? Yeah, 3.3. And so they're not the same. When we take 10.8 minus 8.1 is going to be 2. 2.7. 2.7. Okay, well, you can see we're not linear because we don't have a first difference. It's common. Next we have 12.8 minus 10.8, that's going to be 2.0. And then we have 14.0 minus 12.8, that's going to be 1.2. So these are our first differences. Next, we're going to graduate to second differences. See what we have. We have 3.3 minus 3.8, that's going to be negative 0.5. We have 2.7 minus 3.3, that's going to be negative 0.6. We have 2.0 minus 2.7, that's going to be negative 0.7. And then we have 1.2 minus 2.0 is going to be minus 0.8. And so our second differences are not the same, so we are looking at eliminating quadratic. And finally, we go to third differences, and we should be able to see we're not exponential at this point. Then we subtract here. We have negative 6, negative 0.6, minus negative 0.5. We're going to get negative 0.1. And so we get negative 0.1 across the board, negative 0.1, negative 0.1. So cubic is our correct answer for this. Next, 7. The graph function shown, what is the domain of the function? Again, like I showed in that earlier problem, I think it was 2. Domain, range. Okay. Domain is our x values. We're looking at x values. So we start here. Looks like we have upside down kind of square root curve. We start here at x equals negative 4, which definitely we eliminate C and D. They don't have anything about negative 4. And which one's going to be between negative 4? Well, we have bracket, but we're not coming from negative infinity up to negative 4. It's not A. The answer choice is B. We start at negative 4 and go up toward positive infinity. So B is our correct answer for 7. 8. See, it's a kind of glitchy, this computer. Waiting. Okay, here we go, finally at 8. Select values for a quadratic function are shown in the table. It really helps to understand what a quadratic function looks like. And a quadratic function looks something like this. In fact, you have 0, 7, 1, negative 2, 1, negative 2, 2, negative 5, 3, negative 2, 4, 7. So we have something that looks like this. And that's what the thing looks like. It says, what is the domain for the inverse of the function? Well, for the inverse of the function, x's become y's and y's become x's. So instead, we would write this function as, we'd have f of x here in its inverse. So we just switch x and y's. So we have 7, negative 2, negative 5, negative 2, and 7. And then over on the other side, we have 0, 1, 2, 3, 4. And what I'm going to do for this one is go to list and spreadsheets, see what happens. And I'm going to go to Control I. Show up. Come to life calculator. There we go. Oh. Okay, there we go. All right, data, list and spreadsheets. and we have x and y. X. Okay, I'm just going to put the numbers in here. 7, -2, -5, -2, and 7. And then come over here, and we're going to do the y side. Y, 0, oops, put 1 there. 0, 1, 2, 3, 4. There we have the points. And we're going to go to data and statistics, control I, and data and statistics, here we go. And we should see our points there, and they're kind of randomly assigned. So we go to tab and choose X, and then go to tab again, choose Y. That's what our sideways parabola looks like. And what it is, you should be able to see that our far left is -5, and we're going up toward positive infinity. So our domain of its inverse function is going to be starting at -5 and going up toward positive infinity. D is our correct answer. Number 8. Next 9. Using a credit card can quickly cause a person to fall into debt if they not fully pay off the account balance each month. Okay, so on. And so what you're looking for is you just look for x's become y's and y's x's. Okay. So here's the original right here. We just want to do a reverse of this. And so where do we see that? Well, it seems really strange, but the correct answer is going to be answer choice A, where x's become y's and y's become x's. All right. Gosh, B is the same thing exactly. Okay, A is your correct answer. So your month becomes your output instead of your input. Next, 10. Daisy's comparing and contrasting the 3 functions shown. What I'm going to do is I'm going to get to graph these in the graphing calculator. We're going to look at those and say which of the functions have the same range. And if you're familiar with these types of functions, linear function f of x, a quadratic function g of x, and a square root function h of x, you'll know what the answer is already, but I would say go ahead and graph these things. Put control I and add graphs. We're just going to graph them. And the first thing we're going to put is f of x equals 2 times, parentheses, x plus 1. And then come over here to the right, minus 2. So that's what we have. That is our first function. What is the range of that? It looks like that range is all real numbers. Next, we go to tab, put a second equation. We're going to put in quantity x plus 1 squared, and then we're going to subtract 2. So definitely you see the range, this red one, this quadratic function is not the same, so definitely they're not the same. So let's go look at that third function. We have h of x equals 2 times the square root of x plus 1, and we come outside and subtract 2, and there we have it. Okay, I don't know if you see this black one here. And so those last two, g of x and h of x, are the same. And so what we're going to do is g of x and h of x are the same, and that gives us answer choice C. That is our correct answer. And this is one that I'm hoping that a lot of you can do without having to resort to a graphing calculator, but even just be sure, use your TI Inspire calculator or even your TI-84, whatever. Okay, the value of vehicle 11. The value of vehicle period of time is shown. At what rate as a percent is the value of vehicle depreciating? What we have is when we find percentage, we talk about a common ratio, and a common ratio equals a sub n divided by a sub n minus 1. So what you're going to do is take two terms that are consecutive and divide them. So in this case, we're going to have $11,040 divided by 12,000. And we go to our calculator and we say, okay, 11,040 divided by 12,000. We get to 23 over 25, and to get a decimal equivalent, we press Control Enter. We get 0.92. And if you're not careful, you might be tempted to write in 0.92 as an answer. But when you're talking about exponential functions, your rate or your base of an exponential function is equal to 1 plus your rate, okay? And so in this case, 1 plus r is equal to 0.92. And if you subtract 1 from both sides, you get r is equal to 0.08. Okay? And actually it's negative 0.08. So we say that's going to be negative 8%. And so it says, what is the value as a percent? Is the thing depreciating? Well, we say it doesn't depreciate at a rate of negative 8%, but depreciates at a rate of 8% because depreciate takes the place of that minus sign. So we're going to say 8%. So we just fill in this 8. And yeah, we can fill in the plus. I think one tendency, like I said, is to put minus in here for that. Next, 12. The students are trying to determine the best model for a given data set. Each student creates a model using the table shown. And we have a common difference, which is first difference, and second finite difference. So we can just go to work on differences and see what they're looking like. And we know on the left side we're going plus 1 every time, so that's easy. On the right side, we have 8.1 minus 1.7. That's going to be 6.4. Is that right? 6.4. And then we have 22.7 minus 8.1. I'll just go to my calculator. 22.7 minus 8.1. 14.6. That's 14.6. Next one we have 45.5 minus 22.7. We get 22.8 for that one. And the last one we have is 76.5 minus 45.5. That's going to be 31. So definitely you're not talking about a linear function. A and B would be linear functions. And then we're going to now go to our second differences. 14.6 minus 6.4, that's going to be 8.2. 22.8 minus 14.6, 8.2. 31.0 minus 22.8, 8.2. What is our answer for this? That'll be D. That's our second finite difference, 8.2. Next, 13. The graph of two functions shown are the two functions inverse of each other. Yes, they are opposites. No, they don't reflect about the line y equals x values. One thing we talked about quite a bit is that for a function to be inverse of each other, they're going to reflect about the line y equals x. What I'm doing here, these blue dashed line, I'm drawing the line y equals x. So it's y equals x. Okay, are these reflecting about the line y equals x? No, reflecting about the line y equals x would look something like this, right? That's what that would look like to be an inverse, not this one down here. So no, they do not reflect over the line y equals x. B is your correct answer for 13. And of course, these ones are reflections about the x-axis. Okay, right? They reflect about the x-axis. That's true, but that's not what an inverse function does. It reflects about the line y equals x. Table value 14. The table values for functions shown. Which type of function best models the data? Well, we notice on the left we're going up by 1, as we've seen before. And so now we can just look at the right side, see what happens here. 4.9 minus 6.7. What is that going to be? Down, it's going to be negative 1.8. Is that right? And negative 1.8. And then 3.1 minus 4.1, negative 1.8. 1.3 minus 3.1, negative 1.8. Negative 0.5 minus 1.3, negative 1.8. These are first differences. Definitely linear. Okay, first difference is being equals linear, second difference is being equals quadratic, third difference is being equals cubic. Okay, the last one we're going to look at in these sample problems is 15, absolute value function. You have fx equals quantity, absolute value of quantity 2x minus 5 minus 4, quadratic function g of x equals quantity x plus 2 squared minus 4, and a square root function h of x equals square root quantity x plus 6 minus 4 are shown on the coordinate grid. What key attribute is shared by all three functions? And we should see that we have a same, I'm drawing a lower boundary here in red to all these, right? And what is the value of that lower boundary? That's going to be y is equal to negative 4. And so that's our minimum value, y equals negative 4, or let me say, don't say y equals negative 4, but that's what value means. So that's going to be our answer. So anyway, there are going to be 24 problems on the actual test as opposed to these 15 we've gone over, and it should be the same type of rigor, generally same type of scope of what we see here. So I encourage you to consider these carefully, and other supplementary problems you're going to use to reinforce what we're seeing here. Good luck, and thanks for viewing.